Hello again to your channel of Math and Engineering Made Easy. Today I'm going to discuss quickly about the 3D stresses using Mohr Circle. Uh, well, the first thing I wanted to say is that sometimes we have the stresses only in 2D, but the maximum shear occurs outside of the XY plane. Well, it turns out that when you calculate your principal stresses sigma 1 and sigma 2, you get one of three cases. Either both of them are positive, like our case, our example, or one is positive and the other is negative, like I think the example we did an example like that in the first session, or both of them are negative. When one is positive and the other is negative, the maximum shear occurs in the XY plane, like 45 degrees after from the principal axis. But if they are both the same sign, then the maximum shear will not be R that you see here we said tau max. It's tau max in the XY plane, but it's not the maximum shear that the element is subject to. I kept this to show you something. Let's redraw the Mohr circle. Okay, so I'm going to redraw the Mohr circle. I kept the page so that we use the same numbers. In this case, remember we had we found sigma 1 and sigma 2 to be what, 50, 81. And 0, the mean here was 35. So when you subtract the 1581, you get 1990. So the 0 is somewhere here. Okay. And since sigma 3, because both of that, notice we had sigma x and sigma y, we got sigma 1 and sigma 2 belonging to that plane, but sigma 3 is the origin because Z didn't have any stresses, so the stress on it was 0. The normal stress or the principal stress was 0. Now, we have three types of shears. If that was the plane that was, that's the plane of the principal axis, that the one that doesn't have any shears. And the radius here is the maximum shear in the XY plane. But guess what? I can draw two more Mohr circles. One of them here, and one of them here. Excuse my drawing, I know. Do you see the big circle? Its diameter is 5081, meaning its radius is 2540, which is higher than, of course, higher than 1581. So the maximum shear occurs somewhere between the sigma 1 and the z-axis, or so it's a tilted plane. If those were, so on the other two cases, or the other case is that if I draw Mohr circle and I get something like that, okay, I get sigma 1 here, and I have, this would be sigma 3, by the way, not sigma 2. Why? Because sigma 2 is the origin. Remember, the third axis, the z-axis doesn't, or the z doesn't have any stresses, so that would be sigma 2. If I want to draw the circle between sigma 1 and sigma 2, it would be smaller, and of course between sigma 2 and sigma 3 is smaller, And the maximum shear is between sigma 1 and sigma 3, which are in the xy plane. So if one is positive and the other is negative, the maximum shear occurs in the xy plane, stays in the xy plane. Turn 45 degrees from the diameter sigma 1, sigma 3. But if are both positive or both negative, the maximum shear would occur outside of the xy plane very quickly, right? In some problems, they give you sigma 1, sigma 1, sigma 2, and sigma 3, and all of them have stresses. So they are not all, not one of them is 0, okay? So they tell you sigma 1 says 20, and sigma 2 is 15, and sigma 3 is 8. And maybe you will have also like a point on Mohr circle that has taus, or tau, maybe tau xy and tau yx are there. And you want to find the maximum shear. You can also use a 3x3 stress tensor and use that to solve eigenvalues and eigenvectors. It would be, most of the time, it's whoever makes the problem makes it easy, but it would be more cumbersome to try to find the principal axes using eigenvalues, because it's a 3x3 matrix, not a 2x2 like the one we did last time. That was trivial, right? So on the main diagonal, you will have the 3 stress. We could have added here a 0, and maybe we had shear. So, and we could find the principal axes if this number wasn't 0. So if I have like 40, 30, and then maybe 15 or something. So we could have done that. But most of the time that will give you, in fact, in that case, Mohr circle would be easy. And of course, you have the equations as usual. I don't like to memorize, or I don't like you to memorize equations. I would like you to understand and then use what you get. I hope this was easy. I mean, of course, the drawing is horrible, but we say here tau max, so we could have said this is not tau max. This is tau max in the xy plane, but tau max here would be sigma 1 minus sigma 3. In this case, sigma 3 is 0, but it may not be 0. I may have all 3 values, so that might be 5, for example, okay? Over 2. Why? Because sigma 1 minus sigma 3 give you the diameter of the big circle. So you divide by 2, and that would always be the maximum. Excuse me. I think that's it. It's a very short session, but I just wanted to show you that if sigma 1 and sigma 2, both of them are positive or both of them are negative, then the maximum shear doesn't occur in the xy plane, and it's larger than tau max in that plane. Okay, thank you very much for your time, and hope to see you soon. Bye.